need to delete a bunch of, actually, you know what? I'm just going to start this whole program over because that would be quicker. I've got a whole bunch of pages that I don't need. I had a little note card laying around here for the basics of this. So I think once you get into this, it's not hard at all. Usually what I find with this unit is that it's just the newness of the language. So we're going to be talking for the next couple of weeks about two things. The first one will be sequences. And then eventually we will talk about series. And a series is, again, I'm just throwing this out there because this is not on today's agenda. But if you ever hear someone refer to that, a series is basically like if you take a sequence, like we're going to learn about today, and you actually add all the terms of the sequence together, then you get what's called a series. So, like if I just wrote 1, 2, 3, 4, 5, dot, 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 that's an arithmetic sequence. But if I were to add them like 1 plus 2 plus 3 plus 4 plus 5, the moment you add them together, it becomes a series. So the series probably will be something that we don't even discuss for at least another week or so. So today, tomorrow, we focus on sequences. So there are two types of sequences that we'll discuss. There are other types of sequences that you can find in mathematics, but the two that we discuss in high school, which I don't think this comes up really a lot in any other class, but the ones we're going to discuss are, do you know this word? If you use it as a noun, you would say arithmetic, but it's not a noun. In this case, it's an adjective. And as odd as it is, you have to change the pronunciation. It's now a descriptive word. And so you have to put the emphasis on the other syllables. And so it is called arithmetic. You kind of have to um, you put emphasis on the different parts of the word. And we're going to talk first about an arithmetic sequence, okay? And an arithmetic sequence is one in which the same number is added or subtracted as we go from term to term. So a really simple example of an arithmetic sequence could be something like this, like 2, 4, 6, 8, dot, dot, dot. And get used to doing those dot, dot, dots. They're not down low like you would in English class, they're up higher. And the dot, dot, dot just indicates basically like ad infinitum. Like, yeah, it just keeps going. So you see, well, first off, obviously it's a sequence and you can see a pattern, right? So, not everything that has a pattern is an arithmetic or a geometric sequence. But in this case, you can see the pattern is that we're going plus 2, plus 2, plus 2. So because we're adding the same exact amount every time, we call this an arithmetic sequence. Arithmetic sequences can also go smaller. You don't have to add the same positive amount. You can also add a negative amount. So for example, say you started at 13, and then you had 8, and then you had 3, and then you had -2, dot, dot, dot. I mean, I make mistakes, we all do, but hopefully we're not going to make a lot of mistakes with just like basic rinky dink arithmetic, right? What is being subtracted or added each time? Yeah, so like if it depends on the phraseology, right? By definition, we should be saying that we're adding -5 each time, because to be an arithmetic sequence, by pure mathematical definition, you have to add the same number each time. I get it. But so if the math gods were to say do this properly, I would say we're supposed to phrase it as we're adding -5 each time. But I'm okay if just in casual language, if we just say we're subtracting 5 each time. Oh, that's a great question. So just so you know, like if you take more math classes and someone says, what's D, you'd want to say -5 and not 5. And we'll talk about D here in just a second. So those are examples of what we call arithmetic sequences, and we'll come back to that. There's a lot of meat on the bone today, but I just wanted to kind of show you what it is. So very simple arithmetic sequence. The other types of sequences in this class that we're going to talk about are geometric. And let me put a geometric sequence up here, and you see if you can crack the code and tell me what a geometric sequence is. 3, 12, 48, 192. It's clearly not arithmetic, right? Like, whoa. Because if it were arithmetic, then you'd start by saying, okay, I added nine, and then you'd add nine and go, I'm nine. So what do you think is the behavior of a geometric sequence? So what do you think is the behavior of a geometric sequence in general? There you go. It's multiplication by the same amount each time. So it doesn't work for this to say I'm going to add the same number. I am, though, going to multiply by the same number. And again, all of this is predicated on a logical assumption that your basic skills are up to snuff enough that you know how many times like 12 goes into 48. Yeah, Diedrich. Yes. And geometric is multiplying and dividing. And as we get more comfortable, I'll go back to that little side conversation I was having with Miss Orozco. Once we get our kind of feet more settled on the ground here, I'll go into more picky detail about what I mean by technically arithmetic is always adding and geometric is always multiplying. But again, maybe that's a conversation for another day. It's all good. So this is a geometric sequence. You can see clearly that it's 3 times 4, next one. 12 times 4, next one. 48 times 4, next one, right? And as you would assume, it also works if you're going back down the ladder. So if I had like 12, 6, 3, 1.5. Can you see the geometric nature of it? How are we going from one term to the next? We're dividing by 2. But again, if I were a college professor and I were really, really wanting to hold your feet to the fire on this, I would require you to say we're multiplying by 1/2. Okay. But again, with us just hanging out here in Burns during 7th hour in room 135, I'm totally fine if we just casually say, like if we're just talking casually, let's just divide by 2. But the understanding that it's times 1/2 will be critical to when we find the R value and we go to write formulas. So you'll see. But if I were to put that up and you go, it's divided by 2, like I'm not going to bite your head off or anything like that. But it won't help you with the formula. So anyways, are you good on what an arithmetic sequence is and what a geometric sequence is? Okay, good. So what I wanted to put up here next is the just kind of I wasn't really sure what order I wanted to do this in, but I'm going to put an arithmetic sequence up here. And there really is a decent chance that you get lost at some point today. And you won't get lost because the math is hard. You'll get lost because it's just a lot of weird stuff. You'll look back on this in a couple days and be like, wow, I remember when I thought all that a sub n equals a sub 1 plus n minus 1 times d stuff was tricky. And then you go, it's not, I get it now. Like I see what it all means. It's not bad. So, if I were to just casually ask you, what's the first term of this sequence, what would you say? What's the first term of this sequence? To answer the right question, okay, it's 3. Good. If I were to ask you another question, like what does the sequence go up by each time? What would you say? 4. So what you just found for me are 2 very important things that you're going to need. I hope you're still paying attention because we got a lot to go. So when I asked you what's the first term and you said 3, you just found something for me called a sub 1. And if you hear me say that, I'm going to write this down. It's a sub 1. So when you hear me say that, I know I sometimes have kind of a nasally voice and it's hard to understand. I'm saying a sub, S-U-B, like that's how we say subscript. I'm heading down. So throughout the next couple of weeks, when hundreds and hundreds of times you're asked to find a sub 1, someone is really just in nerd code speak saying find the first term of the sequence. So we just discovered through casual conversation that a sub 1 is 3. I also asked you another question and I said, what does the sequence go up by? And you guys recognize that it goes up by 4, right? So you found something else for me called D, and D is 4. So let's add this to our notes so that you can certainly, look back someday and make sense of this. A sub 1 is the first term. By the way, if I wanted the 34th term, I would write a sub 34. If I wanted the 10th term, I would write a sub 10. So that little subscript just represents how far into the sequence am I. That's all. And then D is what we call the common difference. And that's just a word that we use in math to represent how far one number is away from another. So we good on those two terms? Now, finally, we're almost there for this. And once we do arithmetic, the geometric won't feel so awkward because this is all, I'm about to blow you up here in a second, but let's go easy. If I asked you for the fourth term, could you give it to me? What is it?
14.
It's 15. If I asked you for the fifth term, could you give it to me? It's 19. And see, all of that is, again, predicated on the assumption that you know the term before it. Like if you know the third term, you add 4. Duh. If you know the fourth term, add 4. Duh. If you know the fifth term, add 4. Like so on and so on, right? So where we run into a pickle is the question I'm about to ask you. Can you find me the 153rd term? And we spend time in this unit talking about formulas because really, honestly, we can't really go far without them. Like again, if I said, find me the 153rd term, if I asked a very motivated fourth grader, if I said, I'll give you $20, like maybe is that a lot for a fourth grader? I don't know. Here's $20. If you can find me the 153rd number in that purple sequence, and I'll give you 20 minutes. Could a motivated fourth grader do it? Absolutely. They could just keep very meticulous track of how many times they've added 4, and they could keep going. And when they know they've gotten to the 153rd number, they'd go, I got it. Can I have my $20? We agree, right? But I mean, we're not cavemen, right? That's not the way we do mathematics. So this is where the formula that I'm about to give you shows its usefulness is that I don't, yeah, okay, good. I know the first term. Yeah, yay, I can see the other terms, the early ones. But when someone busts this out and says, what is the 153rd? Or what's the 6,924th? Like, ain't nobody got time for that, right? So I'm going to put a formula up here on the board, and I want you to write it down, and I want you not to get upset or anything. I just want you to understand what its purpose is. And its purpose is to give us any term that we want, provided that we know some early, easy things about the sequence. Okay, so I'm going to get rid of this geometry here. We'll come back to that. So this is the formula, by the way. This is called the explicit formula for the nth term of an arithmetic. Eventually, we will learn about recursive formulas, but today we're going to talk about explicit formulas. And I didn't really ever understand the difference between those. So you'll get no grief or sarcasm or judgment from me if you really struggle to get your head around the difference between explicit and recursive. But today we're all explicit, just for the record. So an explicit formula gives you the ability to just go right in and do what you need to do. And this is what the formula says. I'm going to write it in a color that I haven't used yet today. I'm going to use yellow. So here it is. It says if you want any term in an arithmetic sequence, that's a sub n. N can be anything you want. You have to take the first term, a sub 1, and add the quantity of n minus 1 times d. This is going to become a very prized possession in your arsenal. So make sure you get that down correctly. And it might not happen today. It might not happen tomorrow. But the first time you see how logical and easy that formula is, you'll be like, wow. Like if you're a super mathy person, you might already have put the pieces together and said it makes sense. But let's think about this. To get to the 153rd term, I really need you to be a part of this now and answer this question because this is a good one. To get to the 153rd term, how many times would you have to add 4? Okay, let me ask you another question. Nope, I'm going to keep it the same way. So we start with the number 3, right? How many times would you have to add 4? Because that's what the sequence says, right? It's plus 4, plus 4, plus 4. So how many times would you have to add 4 to get to the 153rd spot? Again, math guy to the rescue. You would have to do that process 152 times. Think about that. If you were standing on a number line on the number 1 and you wanted to get to the number 5, you would need to take 4 steps, right? Do you see what I'm saying? So the formula isn't actually, and again, you may not be ready to even think about what I'm talking about. The yellow formula is actually not as far-fetched as you might think. It says start here and then add the common difference this many times. Done. So anyhow, we'll come back to that when you're ready. But at this point in time, if I said to you, find the 153rd term, you'd go like this. I got you. A sub 153 incoming is what? Now, what are we going to put in place of A sub 1? 3 plus. Now, watch out. I'm asking you for the 153rd term right here. I'm gonna go with a little bit of green. What is 153 minus 1? So I'm going to do 152 times. And what did we say D was? Thank God we have calculators. By my mental math, that looks like it's like 611. Is that close? I'm seeing 4 times 150 is 600. 4 times 2 is 8. 608 plus 3 should be 611. So what this means is this, that if Evie sat there and just said, I don't know what you're talking about, Mr. Ayer, you crackhead, but I can tell you this. Evie sits there and she writes out all 153 of the first numbers of the sequence. When she finally goes, thank God, she's on the 153rd one, it's going to say 611. That's how you utilize an explicit formula. As long as you know the first term and as long as you know the common difference, easy peasy. Yep. Which one, bud? I did. I put it right. Oh, let me put some. I'm running out of colors here. Let me put white around it. I put it right there, but
How did you get 152?
we'll come back to you. One second. I filled it, so N just became 153 right there. No, A. Oh, grouse. See, that's where the confusion can start. A never changes, bro. A is a general letter that we use to just represent that we're talking about sequences. So don't think of A as a variable. That's a great question, my man. A is not really a variable as much as he is just like an identifier. Like, does that make sense? Yeah. What's going to change are the N's and the D's and the R's and stuff like that that you'll see. But A is just what he is. So the question was asked again, how did I get 152? And I'm going to come back to what I said before. There's two explanations for this. Explanation number one is this. If you start at the beginning of the sequence and you add 4 right there, you get to the next term, right? And if you add 4 again, you get to the next term, right? If you repeat that process of adding 4 152 times, which term will you be at? Think about this. If I do it once, I'm at the second term. If I do it twice, I'm at the third term. If I do it 3 times, I'm at the fourth term. Do you see what I'm saying? So to get to the 153rd term, I have to do one less than that, 152 actions. If that doesn't make sense, then there's always this explanation, and this one never fails. If you're looking for the 153rd term, just take one away, stick that number right there. Done. Game over. So if I said, hey, Shariah, what's the 54th term? You would just put 53 in place of n minus 1. Got it? Okay. Let's practice again. Let's do 26, 23, 20, dot, dot, dot. And I would like you to find the 38th term. You file this under stuff that shouldn't need to be said, but is going to be said. We're not going anywhere until we put this out. What's A sub 1? 26. A sub 1 is the first term. A sub 1 will always represent the first number in the sequence. And what is D? And don't say 3. It is negative 3. Good. So because we're subtracting going down, our D, our common difference value is negative this time. And I'm telling you, with the things that are on the board, in fact, I'll circle them in yellow. Those three numbers in yellow are all you need now to get your answer. I'll write the answer in green and hopefully my answer and your answer match. Was that was a thumbs up I saw back there? Awesome. That's a thumbs up. Awesome. Good. Forgot about that, did you? Yeah, you gotta add that starter. It's important. And I again, sometimes I sit up here and I teach something and I'm like, I can't believe people don't get this right away. This is not one of those things. I will understand if you don't get this right away. It feels weird until when your brain's ready for it not to be weird, it's just gonna like a light bulb. You'll see. Till then, it's pretty weird and frustrating. Did you get negative 85? Okay. How'd you do there, Evie? Good. Awesome. So really all I'm doing is plugging in numbers. And so just look, it's all about the formula, really. I hate to say that. I mean, I'd love it if it weren't just the formula, but honestly, remember this, according to the formula, is where we always put a sub 1. This, you'll remember, is where we always put n minus 1. And since my bossy teacher said to find the 38th term, I just took one away. That's why I put 37 there. And then the number that goes back here is always D. You just plug those in like a robot. Boom, boom, boom. It's never going to fail you. Okay. So that's half of your assignment is going to be arithmetic sequences. Good. We don't add those two ever. We multiply and then we add the order of operations. Yeah, of course you don't. Yeah, you don't add those. The times goes first. So you do 37 times negative 3. You just type it all in your calculator from left to right. Just type in literally 26 plus 37 times negative. Just don't ever hit enter until the end. It'll do it for you. But the order of operations, of course, is the boss. Are you guys feeling at this point like you're mildly comfortable with how to do an arithmetic sequence? All right, let's head over. Let's make this official. Tomorrow's obviously going to be a heavy work day, right? But let's finish this while we're strike while the iron's hot. So we're going to head down now. And did you get that to come out to negative 85? Good, good, good. Let's head down now and talk about geometric sequences. So the first geometric sequence that I'm going to put up here is 2, 6, 18, dot, dot, dot. I've got 3 of these because I tried to keep the lesson as short as I could. I was, packaged as tightly and concisely and neatly as you can. We need to do 3 geometrics to get through the notes. So this is just our warm up, nice and easy. It's obviously not arithmetic because arithmetic would be plus the same amount. This is not plus 4, plus 12 ain't going to work for me. So as soon as we recognize that it's times, then we're ready to do some math. So what is the first term? All right, we agree. Like, don't ever get stumped on that. Okay, the first term is literally just like sitting there looking at you. So a sub 1 equals 2. And we're going to use the same notation as we did with arithmetics. The first term is just always going to be a sub 1, whether it's not called a common difference, actually. It's something else, but I'll put that up here in just a minute for you. But anyways, a sub 1 is universal. That will always just mean the first term of the sequence. Good. Now, what does it multiply by each time? Good. And so we are going to say that D equals, I'm sorry, not D, don't write that down. God, I was on such a roll and then I screwed up. R equals 3. Boy, that was a little rough 30 seconds there. D is what we use for arithmetic. That's the difference. R stands for something else. It's called a ratio. So I don't think I need to write into your notes what A sub 1 stands for because you already know what that is, but I do want to put into your notes what R stands for, and it is called the common ratio. Hence our choice to use the letter R. So in the formula that I'm about to bust out here in about a minute and a half, when you see the letter R, it's kind of like what D was in the other formula, like however much we added each time. This is going to be what we multiply by each time. Good. All right. So if we were to talk in plain English, we were able to look and just go, I see the first term. Being good at basic math, we were able to recognize the whole times three pattern. And now, like I did before, I'm going to put the formula for the nth term of a geometric sequence up here. So this is the formula for the nth term of geometric. And it's interesting because like multiplication and division should feel harder to do usually, like they are in grade school. For some reason, as we get older, multiplication and division become like, I don't know if it's easier, but the formula, I think, to this one looks less intimidating. So to do the nth term of a geometric sequence, you are going to do this. You're going to say that a sub n, in other words, any term is equal to the first term times the common ratio to the power of n minus 1. Like that. And again, prized possession, take great care. If you can't read any part of that, let me know so I can clarify. And the cast is like the cast is set. Like we know what R is, we know what A sub 1 is, and the question now is, okay, bring it. What do you want me to find? You want me to find the fourth term? Like I don't need a formula for the fourth term. You agree? How would I find the fourth term? Where? This right here? That's a multiplication sign. Yeah, you're fine. But anyways, back to what I was saying. If I asked you to find the fourth term, I would expect you not to use the formula because you would be like a genius. I'm just going to take the third term that you gave me and multiply it by 3, right? So again, we have the conversation of if I said find the fourth or fifth or sixth term, you probably wouldn't bust out the formula because you already know the early ones and you could just go like times 3 times 3 times 3. But you know where I'm heading with this, right? Where it becomes an issue is when I say to you this, find the 12th term. Not saying you couldn't do it by hand. Again, a motivated person could easily go through and just repeat this process a handful of times until they go, jackpot, I'm at the 12th term. Here's your answer. So, but we're going to bust out the formula for this. So the thing in the yellow box, that's our guide, right? So the way we're going to write this down, here, I'm going to slide this down a little bit so I can scroll up a little bit like such. So to find the 12th term, I'm going to write this in red, and here it goes. We're going to say, I'm ready for you, A sub 12. By the way, A sub 12 is nothing to do with math. That's just my way of throwing it down and saying to the world, hey, everybody, you're on notice. I'm about to find the 12th term. That's all that says, okay? A sub 12 means nothing other than that. It's a statement. Now, on the right side of the equal sign, we're going to get our math on. What are we going to put in place of A sub 1? Correct, 2, because that's the first term. What are we going to put in place of R? And I like to put parentheses around that for reasons you'll see here in a couple of minutes, okay? I like to do it that way. I don't put it in the formula, but I usually do it in here. And okay, here it goes again. The conversation is this. I want the 12th term. I need 11 for my number, don't I? Because what's 12 minus 1? 11. So my exponent is going to be 11. To get to the 12th location, you must move 11 times. And until you say that to yourself until you really buy it, because that's true, right? There was a Curious George episode about that. Like the man in the yellow hat was like, George, to get to the fourth house, don't move 4 times. Like, go to the 3 moves or something. I don't remember. It was a long time when the kids were little. Anyhow, be careful with this. Let your calculator do all the work for you. Do not hit enter after you do 2 times 3. You'll get it wrong every time. So just type it all in and flow it. Just 2 times 3 to the 11th power, and it's big. It's this little up arrow right here. Say again? Yes. So the answer is 354,209. So if Diedrich sat down and said, I'm doing this, I'm just going to keep hitting times three on my calculator until I get to the 12th one, by the time he wrote down the 12th term, that's what it would say. Any questions about that? It is 329. So we're going to wrap this up with two more examples and then we'll be done. And then tomorrow we'll obviously. What's the matter,
Hey, they're color coded right now.
You don't have to put the parentheses in. Just put in 2 times 3 to the 11th. I don't know. Only you know the answer to that question. Evie, did you get this okay? Wonderful. You ever done this before? Okay. So these last two examples serve very specific purposes, and you'll see what they are. I probably won't even need to tell you, but the first one is going to go like this. I'm going to pause this recording really quickly, resume, and I won't use any more. So, okay, so this is where, and this is what I was talking about earlier is, listen, if we're just talking casual. You're like, hey, look at that. It divides by 2. And like, I got no issue with that. But where we run into trouble is we must not see this as times 2. We must not see this as divided by 2. I'm sorry, but you don't have a choice. You must see this as times 1/2. It's the only thing that worries me about today is that could make some of us uncomfortable. When something divides by 2, by definition, it is actually multiplying by half. Mathematical, like real math purists would tell you that there are only 2 operations, and they are called addition and multiplication. Say, what about subtraction? A pure math person would say, that's adding a negative. I proved my point. And then you go, what about division? They'd say, it's multiplying by the reciprocal. Like real math purists will tell you division and subtraction don't exist. They may not say it like that, but that's kind of the point. So having said that, here we go. What is the first term of this sequence? So we know how to write that down. We're going to write a sub 1 equals 108. What is r? It is 1/2. Yeah, and if you guys want to use 1/2 is fine. You can also, if it's a nice one like this that converts to a decimal, I've got no issues with you using 0.5. Where we're going to run into trouble is if it's 1/3 and you throw out some nonsense garbage about 0.3, then you and I are going to have to throw some hands. So like my safest answer is that's why math teachers are the way we are. It's just that's why we always love fractions. Fractions are always exact. They're always perfect. Okay, so having said that, again, you get the point. If I said find the 4th term, you'd be like, come on, man, it's 16. Okay, fine. Find the 5th term. Dude, it's 8. Like, we get that. We could just keep dividing by 2. But where it gets a little bit tougher is when I say find the 24th term. Could you do it? Yes. Could a very motivated kid with a calculator do it? Yes. Like, I get it. But the point is, and we'll round. Yeah, we'll obviously have to round a little bit here. So, let's first see what it looks like when we actually plug it into the formula. So the formula is going to say this. Okay, I got you. A sub 24 equals, I probably shouldn't have picked 24. That's my bad. I probably should have gone a little smaller, but we're in. Let's go. Let's finish the quest. So we're going to just use the formula. What's the first thing we put in the formula? Yeah, always put the first term first. So 128. And then in parentheses, I'm going to put my R value, which is 1/2. You do need these parentheses, okay, on your calculator. So you're going to type in 128 times open parenthesis 1 divided by 2 close parenthesis, and then hit your little exponent button. What's our power going to be? Always 20, 1 less, right? 23, 1 less. 23 jumps to get to the 24th spot. And then when I type this in, let's see, 128 times 1/2 to the 23rd power. My calculator says something very odd. It says, and I want to make sure that we talk about this so that you know what to do. My calculator says 1.525878906E. Do you guys know what E negative 5 means? It means move the decimal 5 places to the left. So your calculator, when it runs out of real estate, it just puts it in something called scientific notation. That means times 10 to the negative fifth power. So don't sweat it too much. But what it really means is if I take that decimal and I move it to 5 places to the left, because it's negative, I go left, then my answer is 0.0001526 or whatever. Like you could round it off a little bit. Okay. If we were to do this as with a fraction, you and I wouldn't leave here okay today, like we'd be enemies. So we're going to call that good for that particular problem. Questions there? Your problems won't be like that, okay? Yours are much nicer, I promise. Your math teacher's just a jerk. All right, we have one more to do, and then we're going to be done for the day. Happy day. And then I can go home and play Elden Ring, and you guys can go do whatever it is you do. Basketball practice?
Yeah.
Okay. Last one for the day. Here is our geometric sequence. What you're about to see cannot happen with arithmetic sequences, but it can and does often happen with geometrics. This is an alternating sequence. It obviously can't happen with arithmetic because if you add the same positive number or add the same negative number, ain't no way it's going to flip flop back from positive to negative. But multiplication's like his own cat, right? So can you identify already what's multiplying each time? Right. So if your R value is a negative, you can actually create one of these alternating sequences that flip-flops negative, positive, negative, positive, negative, positive. Isn't that neat? So in this case, let's write this down. What is a sub 1? Good job, -5. And of course, what is R? -2. Do you guys, at this point, what a shame this would be, but I would be happy to answer. This far along, I hate to ask. Do you have any questions about what a sub 1 is? It's always the first term, right? And if it's arithmetic, it's D that we write next. If it's geometric, it's R. And let's find, oh, I won't be mean this time. Let's find the, I don't know, let's do like the 11th. This won't be bad at all. It'll be big, but not like crazy big. All right, so this is what's in, okay, as I said earlier, the topic of how do I present my work to my teacher on a quiz that I'll take someday, your work on a quiz would look like this. You ready? Here goes. If I were taking my own quiz, I would write a sub 11, that's the 11th term, equals what? What's my work? What do I write first? Always write your first term first. So -5, and then in parentheses, what's my R? And what will my exponent be? This is money. That to me is like chef's kiss. This kid knows what they're doing. And I wouldn't even expect to see any work beyond this point because I know the calculator is going to do all. -5,120, says Micah. And I don't, I'm going to work it out myself because, so if I do -5 times -2 to the power of 10, I'm getting -5,100. Remember, if you got that wrong, that you either got fat fingers on your calculator or you forgot that to get to the 11th house, you need to move 10 times, right? Evie, good. Double V, you good back there, buddy? So that's going to conclude notes. I'm sorry that it took the whole hour, but boy, did we cover a lot of ground today. Tomorrow, I will go ahead and relock the Delta Math so you can't even see it. And then I'll unlock it tomorrow so that we'll work during class. Deal? And you got your Chromebook yet?